Now, Mr. Cox will start us off with a brief overview presentation. Following the presentation, he will also serve as the NTSB Technical Panel Lead for our first panel, Industry and Government Perspectives and Actions. Mr. Cox.
Thank you, Dr. Dunks, and good morning, everybody. My brief overview, and it's only about 10 minutes long, it's called General Aviation Fixed Wing In-Flight Loss of Control Overview. And it's a pretty long title, but what does it mean and why are we concerned? We really need to talk about some definitions first. Fixed wing and in-flight are fairly easy to understand, but definitions for general aviation and loss of control can be somewhat problematic. For general aviation, there are differences in international and U.S. definitions of GA, and U.S. government statistics collection criteria differ for what industry might consider GA. In the U.S., there's general agreement that GA includes FAR Part 91 flights, Part 125 large airplane non-airline flights, Part 137 agricultural application flights, and non-military public use flights. There's also agreement that Part 121 and Part 135 scheduled airline flights are excluded as GA. In addition, government entities separate on-demand Part 135 flights from GA in annual surveys of the GA fleet. This presentation does include on-demand Part 135 as part of the GA fleet. Definition of loss of control. If we look at FAR AIM, it's not defined, and if we look at the Pilot's Handbook of Aeronautical Knowledge, it's also not defined. There's something called the General Aviation Joint Steering Committee, and there's something called the Commercial Aviation Safety Team, both of which you'll hear about on panel 1. And they use a common taxonomy definition for loss of control, which is an extreme manifestation of a deviation from intended flight path. It's a little bit of a mouthful. A little simpler way to say that would be the airplane won't go where the pilot wants it to go, the airplane does go where the pilot doesn't want it to go, and it's a surprise when it happens. Some of the NTSB common conventions that we use when we do data collection, loss of control in flight is known as a defining event that best describes the accident scenario. It generally involves an aerodynamically sound airplane. It might not be mechanically sound, but is still controllable. Also noteworthy is that in 2008, NTSB updated its database coding, and thus the accidents presented here are from 2008 through 2014. Results also are provided for U.S. registered airplanes on U.S. soil. If we look at the data from the time period we discussed, 2008-2014, we see we have a total accidents of over 9,750 accidents. Total fixed-wing accidents of 8,730. Loss of control in-flight fixed-wing accidents, 1,518, or 17% of all fixed-wing accidents. So 17%, we look at that and we say, that's not such a big deal after all. However, when we get into fatal fixed-wing accidents, we find out of a total of 1,553, that loss of control in flight accounts for 721, or 46%. If we also look at the number of fatalities, we have almost 2,700 fatalities during that time, of which 1,237 are loss of control in flight, or again, almost 46% of all fatalities in the fixed wing. So it's a pretty significant number. We can break this down further by looking at the federal air regulations under which they are flying. As you can see, the green is for all loss of control in flight flights, and the red is for the fatal loss of control in flight flights. And Part 91 far exceeds all of the other ones combined. We can also look at it again as fatalities, and we had almost 1,200 fatalities during that time frame, and all others combined were only 48. Flight purpose, overwhelmingly is personal flight, followed by instructional flight. And incidentally, when I first started looking at this, I was thinking, instructional flight, it must be that student pilot solo, when it's actually the certificated pilot along with the flight instructor most of the times. And then you see the other ones, and they're far less. If we look at lighting conditions, overwhelmingly all accidents, loss of control, 90% are daytime, and fatal accidents are 83%. If we look at weather conditions, overwhelmingly again, we have VMC for both all accidents and fatal accidents. What phases do they occur in? Well, I think we need to talk a little bit about what the phases are. And we go back to our CAST definitions. Takeoff is to 35 feet or gear up in selection. Initial climb is takeoff to first power reduction or 1,000 feet above the runway. En route is basically from the initial climb to the approach. The approach is from the point of a VFR pattern entry or 1,000 feet above the runway to the beginning of the landing flare. And a landing is the beginning of the landing flare until the aircraft exits the runway, comes to a stop on the runway, or when power is applied for a takeoff in the case of a touch-and-go landing. A couple other important definitions are maneuvering, or low-altitude aerobatic flight operations, and the missed approach or go-around from the application of power until the aircraft re-enters the sequence for a VFR pattern for a go-around, or until the aircraft reaches the initial approach fix for another IFR approach for a missed approach. We get our data, we now have our definitions of the various phases, and we can find that by flight phase, maneuvering, approach, and initial climb are the deadliest phases. If you look down near the bottom, landing is actually, there's a lot of loss of control accidents, but they're usually not fatal. We can go a little bit further, and I know this is a busy slide, and I'll go, I've got a couple of follow-on slides that'll make this a little simpler. But if we look at the airport loss of control, again, we have one of our big three, the initial climb, and then we separate the approach, another one of our big three, into IFR, IMC, and VFR, VMC. Again, we look at the landing and flare and touchdown, and there's not a whole lot of fatal activity going on there. If we look at the IFR, IMC, again, there's not very many of them when we look at our big three, but the interesting thing is when loss of control does occur in IMC conditions or on an IFR flight, it's generally fatal. Contrast that with the VFR, VMC, and there's also different parts of or phases of flight where sometimes they are fatal and sometimes they aren't. There is kind of a cluster, though, when we're talking about pattern-based to pattern final, and that would be your skidded turn stall or your cross-control stall. Conclusions. Loss of control in flight counts for about 45% of all fatal GA fixed-wing accidents and fatalities. Overwhelmingly, they're Part 91, day, VMC operations. The major phases of flight occurrence are maneuvering, initial climb, and approach. And then, although a small number of all loss of control in flight accidents, those in IMC conditions approaching an airport will most likely result in a fatal outcome. I hope this brief presentation serves as a good springboard into our first panel, Government and Industry Perspectives and Actions.